Thank you for letting me to be one of the presenters to this visual conference. I'm Felix Khuluza. I'll be presenting on feasibility of low-cost testing techniques for the identification of substandard and falsified medicines in Malawi. Substandard and falsified medicines have been found in almost all the countries in the world, both the high-income countries and low-income countries. But the problem is mainly rife and big in the lower-income countries. This is coupled by the lack of capacity, lack of necessary laboratory reagents, and lack of necessary advanced laboratory system to assess the substandard and falsified medicines. It is for this reason that we aim to assess the feasibility of various low-cost testing techniques for routine screening and identification of substandard and falsified medicines in Malawi. As I have said, as I have read that the normal methods of identifying substandard and falsified medicines is very expensive, which is beyond the reach of majority of the lower income countries. We sourced for various the methods which are being developed or they have been developed so far, and we selected three: the mini lab, pill scan, and the paper analytical devices, based on their availability, cost, and applicability. We sampled 168 medicines used for both communicable and non-communicable diseases. So from these 168 medicine samples, they were all subjected to the three testing technologies: the mini lab, the pill scan, and the paper analytical devices. We are assessing the following parameters for each of the technique. Time to completion for a single sample, ability to identify and quantify the active pharmaceutical ingredient, how much does it cost to assess to purchase it, as well as the routine running costs, and can it be used at any facility or it needs slightly trained personnel to be able to do it or not. Based on the preliminary results, the TLC or the mini lab was the one which was widely able to identify the active pharmaceutical ingredient. So as we can see from this graph, that the black line is the line whereby the TLC was able to identify whether there is an active ingredient or not. So it was almost more than 94% of the samples were able to be identified as having an active ingredient using the TLC. PAD was only able to be used in the about 34% of the samples, as you can see on the yellow lines. And the mini lab, mainly the green lines, were the ones whereby you can only assess, therefore there were fewer samples. In terms of the PAD, apart from just identifying the active ingredient, the PAD, not the PAD, in terms of the TLC, the mini lab, the TLC, apart from identifying the active ingredient, the TLC also was able to identify, to quantify, semi-quantitatively assess whether the content in those active tablets was within the range or not. In the end, we were able to identify the two samples, artemether-lumefantrine and sulfadoxine pyrimethamine, one artemether-lumefantrine sample and two sulfadoxine pyrimethamine samples, which were poor quality. As for the pill scan, I alluded that only was used in very few samples. As you can see, it had only libraries for several brands of artemether-lumefantrine, metformin, and metronidazole. So it wasn't able to be used for the rest of the normal medications, the normal essential medicines which are used in majority of our facilities. That's the setback. In terms of the time to complete analysis, the mini lab was the one which was taking the longest at 45 minutes. And it's just the pill scan is the one which was the fastest. So for a single sample being tested on the mini lab, you could test more than 20 samples from the pill scan. We are finalizing confirmatory analysis, but so far what we have found was the pill scan had also the fewest laboratory waste, unlike the other two methods. However, the limitation for the pill scan, the biggest limitation was that having the plural library, in which the method of doing the plural library is the most expensive. Acknowledgements to funders for this program.